So I am gonna evaluate this limit as x goes to 3 of x to the fourth minus 3 to the fourth over x minus 3, not 4. I'm going to use it using Hopital's rule. I do it in another video using what I call derivative recognition. At this point, I think Hopital's rule is just easier. So what we're going to do is recognize that when I do plug in 3, I get x minus 3 in the bottom. It's definitely 0. And then when I plug in 3 to the top, I get 3 to the fourth power. Now I'm not going to bother evaluating that because it says minus 3 to the fourth here. So I know that when I plug in infinity, I do get 0 over 0. We should identify that as the indeterminate form. And then what I'm going to do is hop this. I'm going to write hop. I'm going to write my limit notation as x goes to 3. Draw my fraction bar. Now remember, with Hopital's rule, we are going to derive the top and put it in the top, and derive the bottom and put it in the bottom. There's no quotient rule. We're just doing these derivatives as if they were their own pieces. So the derivative of this first piece, is 4x cubed. That's just power rule. And then the derivative of this next piece, you may try to say that it is 4 times 3 to the fourth. That would be like trying to, do 3 cubed. That would be like trying to apply power rule to this thing. But notice there's no x in here, right? So this is incorrect. And since there's no x in here, when I derive it with respect to x, it just goes to 0. So I get minus 0. And then in the bottom, I derive the x. That gives me a 1. And then this guy, the 3, derives away to 0. So now what I can do is check what I have here. Notice I have 4x cubed, and then this thing is just not here, so just write it like that. Now, when I look at this thing, I recognize that I can plug in 3 cubed. Plug in 3 for x and not get a problem. So at this point, since I'm plugging in that 3, I can drop my limit notation and write 4 times 3 cubed over 1. Well, the 1 divides in and it just goes away. So I get 4 times 3 cubed is 27, which when I do that, I get 108. And that's it. I'm done.